Okay, good morning class. So today we're going to look at the revision exercise before we go into exercise 2, which is dealing with your first grade 12 exercise, which is your compound angles. Okay. So we're looking at exercise 1. It says use a diagram alongside to find the length of OP. Any issues there? What was the length of OP here? Did you guys do the work?
Yes, sir.
Yes. What's the length of OP? The root of 61. Okay, you applied this. So remember, you're going to conclude this triangle here. So that is going to give you the root of 61 there. That's going to be x is negative 6 and 5, which also confirms the diagram over the coordinates. Okay, remember in coordinate form, you've got the x then a 1. Okay, so the question is for sine of theta, that your reference angle there, sine is opposite, which is 5 over hypotenuse, which is root 61. In 1.2.2, you got 61 cos squared plus 1. So cos is adjacent, which is negative 6 over root 61. Squared is 61 is negative 6, 36. The answer should be 37. Is that correct? That you can put in the calculator. Remember, 180 minus is all stations to Claremont. 180 minus takes you into the second quadrant. Tan is negative, so it's negative tan theta. Okay? So again, if that's my reference angle, tan is adjacent, over, opposite of adjacent. So it's going to be 5 over negative 6. And this negative here is the negative on the outside. So you're going to make that 6 a positive, so it's 5 over 6. Any issues there? No? Let's just take this off here. Look at number 2. Okay. So here people, we need to take the 4 over the equal sign. So it's going to become 7 sine theta equal negative 4. Divide by 7, then sine of theta is equal to negative 4. So what does that tell us? This tells us that sine is negative. In which coordinate is sine negative? 3rd and 4th. Then we are told that cos is greater than 0. What does greater than 0 mean? Positive. Where is cos positive? 1 and 4th. So in which quadrant am I going to draw this in? Into the 4th quadrant. Why? Because I satisfy the fact that sine is negative and cos is positive. Okay. That's my reference angle here, so that's going to be your theta angle. Sine stands for opposite over hypotenuse. So opposite is negative 4, that's your reference angle. Hypotenuse, of course, is 7. Apply Pythagoras, what do I get here? It's 49 minus 16. Something 3. 23. 33. Sorry? 33. Okay. Is that going to be positive or negative? Positive. Why positive? Positive part of the x-axis. Okay. So, number 2.1. So you got 1 minus 49 cos squared theta. So what does cos stand for? It's adjacent over hypotenuse. So the adjacent here is the root 33 over hypotenuse, which is 7. So it's going to be 1 minus 49 cancels 49, 33, which is negative 32. Is that correct?
Yes.
2.2. Tan over cos of theta times tan of theta. So sine over cos is tan. So in other words, you're working out sine theta. Sine is adjacent over hypotenuse, which is root 33 over 7. Or you could have gone straight and said cos is adjacent, which is negative, which is root 33 over 7, multiplied by negative 4 over root 33. You should get the same answer of root 33 over 7. Is that correct? Hello? Is that correct? No. Let's carry on. Take this one first. Yes?
The previous one might be incorrect.
So why didn't you tell me when it was on the board?
Pretty sure, sir.
Sorry?
I'm not sure.
This one here?
Yes, sir.
I also felt like I was incorrect, but you said, and I said, is it right? You said yes. Right, cos is adjacent, so it's root 33 over hypotenuse, which is 7 times adjacent, which is root 33 over, sorry, it's opposite. It's opposite, which is negative 4 over root 33. So it's negative 4 over 7. Okay, so cos is cancelled, which is correct, so sine. So I wrote down the wrong ratio for sine. Yes. The ratio for sine is opposite of a hypotenuse, which is negative 4 over 7. Okay, thank you. Okay. The next question is number 3. Here we are told that cos of A is equal to 5 over 6. So that's mean to say what? Cos is positive. But now they tell you that angle A plus angle B is 90. So they complementary angles. So I can draw a triangle like this. That's angle A, that's angle B, and these are 90 degrees. Why? So 90 at the one end, that means to say that those two angles has to be complementary angles. Okay, they add up to 90 degrees. Now cos of A, cos is adjacent of hypotenuse. So the adjacent here is going to be 5, hypotenuse is going to be 6. So how do I get this length here? Let's call this C. I'm going to calculate BC. Pythagoras. So it's going to be 6 squared minus 25, or 6 squared minus 5 squared, which is 36 minus 25, which is 11. Is that correct? So it's going to be the square root of 11. So what happens now is that if you got tan of A, tan is, now we need, that refers to A, we must use angle A in its reference. So angle A, tan of A is going to be opposite. Now opposite to A is the root of 11 over adjacent, which is 5 times. Now tan of B, I must now use this angle here. Opposite to B is 5. Opposite to A, of course, is 11, root 11. So tan of B is opposite, which is 5, over adjacent, which is the root 11, times cos of A. And now we must use the angle A again. Cos of A is adjacent, sine of A is opposite over hypotenuse, and this is all over cos of B. So again, we must use angle B. Cos is adjacent, which is root 11 over hypotenuse, which is 6. So when you look at this here, that all cancels. Leaves you with an answer of. Now there's many ways of doing this. I could have changed all the A's or all the B's to 90 minus A. Then you're going to use co-ratios. Okay? Or I could have chosen all the A's to be written as 90 minus B. Okay? And replaced that in that formula. Or I play it as it is. Okay? I used it as it is. Okay? The next one is number 4. The question says prove the following identity. So of course in an identity, we can't take things over the equal sign. You must prove the one side is equal to the other. So on the left hand side of the equal sign we call LHS, left hand side. So what can be done here? I'm going to change tan. Okay, so that's going to be cos squared x plus sine squared x times cos x times tan can be written as sine x over cos x. People always in a grade 12 paper, there must be a point where you're going to change tan to sine over cos. Okay. So this cancels here. So that gives us cos squared x plus sine squared x. And what is cos squared x plus sine squared x equal to? 1. Which is also equal to the right hand side. Okay, that is also a must have in a grade 12 paper. You must have a proof there. Okay. The next one is 4.4. Again, it's the proof. So again, on the left hand side, I'm going to change tan. Tan can be written as sine squared theta over cos squared theta. People, this will never cancel. Why? Because it's the plus and minus between. Okay? So it's divided by 1 plus sine squared theta over cos squared theta. So what can be done in the numerator there? What can be done on top? You can find an LCM. Not so. What's your LCM in the numerator? Cos squared theta. So naturally that's over 1. So this must be multiplied by cos, times it by cos, and you get cos squared theta minus. This can be multiplied by sine squared theta. Not so. This line means what? To divide. Okay? So it's going to be divided by cos squared theta, naturally over 1 there. So it's going to be cos squared theta plus sine squared theta. Okay. So what's going to happen here? This is going to change to multiplication at tumble and times. So that's going to become cos squared theta minus sine squared theta over cos squared theta times cos squared theta over, what is sine squared theta plus cos squared theta equal to? 1. Okay. So what can happen now? Cos squares cancel. You know, with cos squared theta minus sine squared theta. But if we look at what we have here, we only have causes. So sine can be written as what? The sine squared theta can be written as what? 1 minus cos squared theta. You all agree with that? Huh? So wrong. What's wrong there? Brackets is, must have a bracket. More than one term following a negative sign. So it's going to become cos squared theta minus 1 minus plus cos squared theta. So it's going to be 2 cos squared theta minus 1, which is equal to the right hand side. Okay? It was very important in grade 11 trigonometry. Okay? I hope you realize that yesterday in your test. Huh? And you knew all the answers already, no? Am I right? Huh? You knew all the answers. So you're going to get full marks. So there's no chocolates on yesterday's test, no? So you had all the answers already. Am I right? Not interested in the chocolates, okay. People simplify each other following. Reduction formula. There we go, all stations to claim. Alright. So 90 minus, which quadrant is that in? First quadrant. Sign positive and negative? Positive, but changes to cos. So it's 2 cos x minus 360 minus. Fourth quadrant. Cos positive and negative? Positive. That's quadrant 1, 2, 3, 4. So it's positive. So positive times this negative remains negative. Cos x over 90 plus. Which quadrant is that in? Second quadrant. Cos positive and negative? Negative. But changes to sin x. Although it changes to sin, cos itself is negative. 180 minus 180 plus. Fourth quadrant. The third quadrant. Sin positive and negative? Negative. That negative times this negative is positive. Sin x. Okay. So what we have is 2 cos x minus cos x is going to give you cos x over negative 2 sin x plus sin x is going to give you negative sin x. So what's cos over sin? What's sin over cos? Tan. So what is cos over sin? 1 over tan. So it's negative 1 over tan. Is that correct? Right. Don't tell me later on that you made I think you made a mistake. You need the space again. You see, if you are wrong, then I can tell you why you are wrong. You understand? So don't be scared to say you think you made a mistake. So, okay. So you got all stations to claim on. 180 minus is in which quadrant? second quadrant. So it's negative tan x times tan 45. There's 1 root 2. Remember, for your NBT, you're going to write a 3-hour exam without a calculator. You need to know this, okay? There's 1 over 1 times cos of negative x. Which quadrant is that in? Which quadrant is that in, people? Fourth quadrant. Thanks, man. Fourth quadrant. It's positive or negative? Positive. Over. 180 minus. Second quadrant. Sign positive or negative? Second quadrant. Positive, yes. So you got 1 negative, so the ultimate sign that's negative. Cos can be, sign tan can be written as sin x over cos x times cos x over sin x. So what happens? That cancels. Negative sign over negative sign, negative 1. Okay. Let's go over the next one. Question 6. Question 6, we are told if tan 38 is equal to k, write down the following terms of k. So tan stands for what? So k over 1 is opposite over adjacent. So we got here 38, your opposite to 38 is k, your adjacent is 1, apply Pythagoras. K squared plus 1 squared is equal to your hypotenuse squared. So it's going to be the root thereof, which is the square root of k squared plus 1. This angle here you always work out. Because that's 190 minus 38. And what's the sign? What's the angle of 90 minus 38? 52. Here we go. 6.1. So tan 142. So tan 142 can be written as tan. Which quadrant is 142 in? Second quadrant. So I say 180 minus 38. We stand positive or negative in the second quadrant? Negative. So it's negative tan 38. Tan of 38 is k, so the answer is negative k. Let's look at 6.2. 6.2 is cos of negative 38. Which quadrant is that in? All stations to Cleveland. Is it your fourth quadrant? Or we can say 360 minus 38. Remember, if I'm adding 360 to an angle, add or subtract 360, I don't change the value of anything. Okay? So that is going to be in the fourth quadrant, so it's cos of 38. What does cos stand for? Adjacent of hypotenuse. So it's 1 over the root of k squared plus 1. Okay? The next one, 6.3 is sine 52. Sine, there's your 52 angle, sine is opposite. There's 1 over the root of k squared plus 1. Okay. No confusion here? No? Alright, let's carry on with our lives. Question 7.1. It says, simplify without the use of a calculator. So again, that is in your second quadrant, so it's going to be sine 180 minus 30. I know most of you do it without this. It's fine, sine of 55, so I need to know this. There should be another angle that couples that thing. So there's not a special angle there. And it's without the use of a calculator, so I know there must be something that will cancel out or somehow or other. Then sine of 135 can be written as 180 minus 45. Tan of 240 is going to be tan of 180 plus 60. And this is over cos 360 minus 30 times cos 180 minus 45 times tan 180 minus 30 times cos of 180 plus 45. I think that's behind the calculator there. So that would simply be sine of 30 degrees times, where's the 55? I think I made a mistake. Okay. This should have been cos of 180 to 90. And is it 90 plus 45? 55, sorry. There we go. So the cos will change to sine here as well. Okay. Thank you. So that is going to be sine 55. times 180 minus. I could have said 180 for this here, just remember that. I could have said 180 minus 35. Then you must convert it again to cos in your next step. So she converted it one time, which is better for you actually. Okay, so 180 minus second quadrant sine is positive, so it's sine of 45 times tan is going to be negative, no, it's positive, tan 60. That's all over. 360 minus 30 is going to give us 360 is cos of 30 degrees times 90 plus is in the second quadrant, cos is negative, so it's negative sine 50 times 180 minus second quadrant tan is negative, so it's negative tan 30 times cos 180 plus third quadrant, cos is negative, so it's negative cos 45. So of course here this definitely cancels. That's what, not 55. Yeah. It's actually cancelling that. It's 2 negative, so the ultimate answer is going to be positive. So I'm not worried about the sign in here. No, there's 3. There's another one. Am I missing another one there? So the ultimate answer is negative. So now 30, 45 and 60 you take it to the special angles there. So it's 30, so it's 1, 2, root 3. And 45 is 1, 1, root 2. You must write this so often that you have no choice but to remember it. Okay. Shukran. People, sine of 30 is going to be 1 over 2. Not so. Times sine of 45 is 1 over root 2 times tan of 60. If you 60 degree tan is opposite of adjacent, it's going to be root 3 over 1. Cos of 30 is adjacent of hypotenuse, so it's root 3 over 2 times tan of 30, so opposite of adjacent is 1 over root 3 times cos of 45 is 1 over root 2. So of course this cancels. The root 3 cancels the root 3. So what am I left with here is a half. That half cancels that half. So what are we left with? Root 3 over 1. So the answer is negative root 3. Is that correct? Yes. Alright, so tomorrow, first half of the lesson, inshallah, we will carry on again with this here. Okay. The remainder of the revision exercise. Otherwise, we're going to spend our lesson on that, okay, which is not why you came to school today, okay? Okay, I know you didn't come to school for maths either. Okay. People in exercise 2, and this is on page. Exercise 2 on page 95. Okay, why do I feel like I'm trapped here? There's no space for me. Let's take this Mickey Mouse off here. Okay, so just get this here. Right, you have to do the first column and every alternate sum, not so? Right. People, any problems with one? Okay, let me just do it. No? That will be better for us, not so? Yes, I know. Yeah. People, trigonometry is very important. Very, very important. Trigonometry was given 10 extra marks from geometry. Okay, normally the trigonometry is 40 marks out of 150. Now it's 50 marks out of 150. Okay. They thought they were making life easier for you guys. No? But you like geometry more than trigonometry, no? Yes. You don't like anything. What's wrong with you people? Right, so let's do our thing. Let's take that there. Right. People, exercise 2. think I must cut it rather from the textbook, it's going to look better. But anyway, it's already on the board. So we know that cos alpha plus beta is equal to cos alpha cos beta minus sine alpha sine beta. Okay. So that would simply be, so cos alpha theta plus 2 beta, this is like your alpha and your beta in other words. So we got cos theta cos 2 beta minus sine theta sine 2 beta. Any confusion there? No. Just look at the second one. Sine 3 theta plus 2 beta, this is the same as saying sine alpha plus beta would be sine alpha cos beta minus plus sine beta cos alpha, or cos alpha sine beta is the same. Okay? So if we do that, in alpha's place we've got 3 theta. 3 theta, 2 beta. 3 theta, 2 beta. Can you see that, people? Verstaan julle? Daar is nou 3. Wat is theta in Afrikaans? Theta, 2 beta. No? Alright. So let's go. It's going to be sine 3 theta cos 2 beta plus sine 2 beta cos 3 theta. Alright. Any confusion here? No, since it's on the board you don't have a confusion, no? When it's not here, then it's a problem. Alright, let's see. So, as I said, I'm rather going to cut from here. We did all the examples, no? Yes, but it didn't help us much. Alright? Don't make as if you don't know what I'm talking about. Right. Okay, so they ask the right expression that follow as the sine or cosine of a single angle and evaluate where possible without using a calculator. So you said again, without using a calculator, we're never going to use special angles. Okay, so this is sine. You see, firstly we check if it's acute angles. Is it all acute angles? Yes. So if that's your alpha, alpha, beta, beta. So in other words, you should be seeing sine alpha cos beta plus sine beta cos alpha. So what is that equal to? Sine alpha plus beta. Not so. So if you apply that, then this would simply be sine. What's my alpha? 68 plus what's the beta? 22. Which is actually sine of 90. And what is sine of 90? That's 360, 180, and that's your 90. Sine of 90 is 1. Right? You guys understand? Huh? Yes, okay. Any confusion here? No? Let's keep that this along. Perpendicular. Okay, so is that angles now? Acute angles? No. So what must I do? Make it acute. Right. We make it acute, so this will be cos 180 minus 72 times cos 180 plus 8. So this is already cos. So I must go sine. Do we have sine? Yes. But the angles we're going to use, we're going to try and incorporate 72 and 8 as much as we can. So it's going to become plus 252 is in which quadrant? Third quadrant. So it's 180 plus 72 times 172 is in which quadrant? 2. So that will simply be sine 180 minus. Can you see 72 and 8 I've used again? You guys understand? Okay, so let's just move this over a bit. Okay, this is a bit better. Okay, there's an 8 behind the calculator. Okay. Okay. So what do we have now? We reduce. So 180 minus in the second quadrant. Is cos positive and negative in the second quadrant? Negative. So it's negative cos 72 times. 180 plus. Third quadrant. Is cos positive and negative? Negative. Making this negative a positive. Cos 8. 180 plus which quadrant? Sorry? 3. Sine positive and negative? Negative. Sine 72 times 180 minus second quadrant. Sine positive and negative? Positive. Sine. So this is what you should be seeing. Cos alpha sine beta. Sine alpha cos beta. So where do you see that? Cos alpha, cos beta, minus sine alpha sine. Can you see that? This is the one. No? So we go. This can be written as cos alpha plus beta. So what is your alpha in this case? Sorry? 72 plus 8. And what's 72 plus 8? 80. So that answer is cos of 8. Okay. You guys understand? Any issues here? No. Well, you guys got all the sums right? You got all these sums right, so I don't have to do this. Oh, the ones I did so far. Like the very next one you got wrong. Okay. Oh my words. That's why I say once it's on the board, that's not the problem. So where's the next one? Right, let's look at the next one. Sine 4x cos sine 3x plus cos 4x cos. Is the identity like it? What identity does this one remind us of? The one dealing with? Cos, yes. But the cos is normally first. So if I put the cos first, does anything change? No. So there we go. Cos alpha, cos beta, plus sine alpha, sine beta. So if there's a plus, then here goes a minus. Not so, people. So what do we have now? It must be written as cos alpha minus beta. So what's my alpha angle? 4x. What's my beta angle? 3x. So what's 4x minus 3x? Okay. Okay? Any confusion here? I didn't have to do the first step here, no? But it's just out of courtesy so that you can see the identity being used there. Okay. I think this 2.7 is the last one of number 2. Are these angles are these angles acute angles? Yes. So this is sine alpha cos beta minus cos alpha sine beta. So what does this remind us of? Sine, cos, cosine. Sine rule. Not so. But here's a minus. So here must go away. Minus. Not so. So it's going to be sine alpha minus beta. So it's going to be sine 80 minus 50. What's 80 minus 50? 30. And what's sine of 30? Okay. Any confusion there? No? Alright, let's carry on with our lives. Okay, this is cut. The top part of this looks ugly. I'm going to leave it so I don't have time now to just redo it. Unless you guys want to stay during break. Okay, am I alone again in the class? Right. 3.1. Use a compound angle formula to prove that. So what are the compound angles? Cos alpha plus beta is equal to cos alpha cos beta minus sine alpha sine beta. When the ratios are the same, the signs are different. When the signs are different, or the ratios are the trig ratios are different, the signs are the same. As we have sine alpha plus beta is equal to sine alpha sine beta plus sine alpha cos beta, sine alpha cos beta plus sine beta cos alpha. So if that is minus, then that would be minus. Okay. So let's go with the first one here. Of course, the left hand side is more complex. Not so? So we go left hand side. So we go left hand side, 90 plus. So it's going to be cos 90. Your alpha angle is 90 and your beta angle is of course theta. So it's going to be cos alpha plus beta will be cos of alpha, which is cos of 90, cos of theta, minus sine of alpha, which is 90, sine of beta, which is theta. Now cos of 90 is 0. So this here is 0 times cos of theta. Well, I could have just pulled the line through. Minus sine of 90. The sine graph. Sine of 90 is 1 times sine of theta. That's simply going to give us negative sine theta, which is equal to the right hand side. Okay. Any issues here? Any questions? No? 3.3. Again, the left hand side is more complex. Okay, so that is going to be cos alpha plus beta. Can be written as cos of alpha, cos of beta, minus sine alpha, which is A in this case, sine beta, which is B in this case. Okay, and this is now plus. Cos alpha minus beta is going to be cos alpha, cos beta, same opposite sign, which is plus, sine beta, sine A cos B, sine A sine B. Okay, you all agree with that? So what do you notice? These like terms, not so. So sine A cos B plus sine A, cos A sine A plus cos A sine A is going to be 2 cos A sine A, cos B, sorry, I'm getting confused here, cos B, minus sine A sine B plus sine A sine B cancels, not so. Which means you say this is equal to the any confusion here? Right? .5. Of course, the left hand side is more complex. So sine cos A plus B can be written as cos A cos B minus sine A sine B. And that is being multiplied by cos A minus B. It's going to become cos A cos B plus sine A sine B. So what do you notice here? The conjugate pair, not so, will result in difference of 2 squares there. So I can multiply the first and the last. So cos A cos B times cos A cos B is going to become cos squared A cos squared B minus sine A sine B times sine A sine B sine squared A sine squared B. So if you're looking at the left hand side, sorry, at the right hand side, you should note that you only got in terms of A causes, so I'll keep that one and change that one. And you got sine squared B, I keep that one and change that one. Change it to what? Cos squared B can be written as 1 minus sine squared B. So cos squared A into 1 minus sine squared B. That minus is this minus here. Okay? So we're going to keep sine squared b as it is. But we're changing sine squared a to 1 minus cos squared a. So we get rid of the bracket by multiplying in here. So that's going to give you cos squared a minus cos squared a sine squared b. Okay? Minus sine squared b plus sine squared b cos squared a. So what do we notice now? We cancel. Negative cos squared a sine squared b plus sine squared b cos squared a. They are like terms, so they cancel them. Not so. So what are we left with? Cos squared a minus sine squared b, which is equal to the right hand side. Okay. Look at 3.7, the 3.9 as well. So again, the left hand side is more complex. Okay, here both is complex. So let's go with the left hand side first. Cos alpha, remember this was sine alpha minus beta, no? Plus and then minus. So for cos, it's going to become cos alpha times cos of beta, which is 30, plus sine alpha sine beta. So your beta angle is 30. So this again takes us to the special angle. So it's 30, so it's 1, 2, root 3. So cos of a remains cos of a. Cos of 30 is root 3 over 2. Cos of a plus, that is going to be root 3, 1 over 2 sine a. So now you work out the right hand side. The right hand side is equal to sine 60 plus a will be sine alpha, which is 60, cos a, same sign, cos 60 sine. So sine 60 is going to be the root of 3 over 2, cos a, cos of 60 is adjacent, which is 1 over 2 sine a. What do you notice here now? They are equal. So that's equal to the left hand side. And the last one, before we break. Okay? The left hand side definitely more complex. So sine x plus 30 will be sine x cos 30. Same sign, so it's plus cos x sine 30 minus, that is this minus here, that will be sine x cos 30 minus cos x sine 30. Okay. So now it gives us, for the 30, we refer to the diagram. Okay. So that is going to be the root of 3 over 2 sine x, which is a half cos x, multiply the negative in, which is negative root 3 over 2 sine x. Negative times negative is positive, 1 over 2 cos x. Okay. So what we have is like terms again, that cancel. And what is a half cos x plus half cos x? 1 cos x. So it is cos x, which is equal to the right hand side. Okay. For tomorrow's lesson, we're going to conclude the revision exercise and the odd numbers of this year. So for homework, I want you guys to do from exercise 2, number 1, 2 and 3. You only do the sums you haven't done from that 3 numbers, okay? The rest of the 4 and 5 I'm going to do tomorrow of the odd numbers. No? Inshallah. People enjoy the rest of your day. Good morning, class.